Hello, good evening. How's the food coma? We're working on that. We're working on it. So, quick question. Who here has not been to an OWASP Ottawa meetup before? So, welcome. We're the local chapter for OWASP. Who has not heard of OWASP before? Who here is just for the pizza? So, we've been a chapter that's been around since 2007-ish. We're completely open. We talk about a lot of different things about security, not just web applications, because of course, now you should know the W does not stand for web application anymore. It stands for worldwide. We had to do something with it. We couldn't choose whiskey, so we stuck with worldwide. We meet monthly. We're just starting to get our groove after COVID. Pizza has helped a lot. Support from organizations like the University of Ottawa has helped immensely in terms of providing this excellent facility. And also Rewind, who is the proud sponsor of our pizza. So I want to, give a big shout out to them. Just a couple of slides to talk about the chapter and what we do. And I'm going to see if I'm going to hit the right key here. Yes. So if you go to this QR code, we will not sell you Bitcoin. It will just be our chapter page in OWASP. It'll give you all the deets, our GitHub repo, our socials, our raison d'etre, how to connect with us, things like that. Sometimes I should say talk about, becoming a member of OWASP in terms of the support. If you become a member of OWASP and specify this is your chapter, then we have access to that money for things like supporting events like workshops in the new year and various things. So there are a number of perks, and you don't just get a funky email that has @owasp.org. There's a number of other things as well. And this is a list of some of those perks. I'm not going to read them all because I'm working on my own food coma. We would like to hear your security passion. We want to hear about what you want to talk about, what really either freaks you out or annoys you about security. We want to hear about it. You got something you want to share about security. If it's security and you're passionate about it, pitch us your talk. If you're scared to talk, well, you can do a lightning talk to sort of get into the groove. Or something else of your that you feel comfortable with. So reach out. We do have a platform that we use for receiving abstracts, but ignore that link. That's going to change in 2024 because this is the last meetup of 2023. These are some of your socials. Memorize it quickly. I'm going to change the page soon. The new one is actually Blue Sky. We got an invite. Yay. Same thing, just maybe less other weirdness. We have a Slack, and so there are channels in there for a number of things, including finding work, talking about jobs, things like that. And you can register yourself. We trust you. Special thanks to people who volunteer and help. Rick for putting together our slides and listening to me rant. Everybody else who also listens to me rant. Mel for helping keep me sane and setting up in yet another different room in University of Ottawa. Chris Shepard, who has his handle here, so maybe I shouldn't have mentioned his name. And he was helping us with the CTF in the new year. OWASP is always producing stuff, including Juice Shop. Who here has tried Juice Shop? So it's an excellent modern testing dojo for practicing pen testing in an environment that will not get you thrown in the slammer. I'm not personally familiar with Wrong Secrets, but I have used Defect Dojo for tracking secrets. So there's always, or Defect Dojo for tracking defects. So there's always interesting projects. I will introduce our presenter a little later because we have a last minute thing, and I'd like to introduce, if you aren't already at the university, I'd like to introduce Vio Onat, who's the co-director of the Cyber Range, who's going to talk to us about a very kind suggestion.
Thank you so much, and welcome to our University of Ottawa IBM Cyber Range. My name is Vio. I'm one of the co-directors. The other co-director is Professor Guy Vincent Jordan, who is traveling this week, so he is not able to be here today. I'm very happy that we managed to bring WASP here in this room that is part of our cyber hub. I know that we've been having meetings on the first floor for a number of months. And we hope that this is going to be the last move. So thank you for being here. We are honored to have you here. And at the end of the session, I'd like to invite you all for a tour of the space. I have a card that opens all the doors, almost all the doors. So we can, yeah, the room with the donuts is on that list. So we can go around if you would like, and I can show you the facility. So thank you so much, and thank you for being here.
Thank you very much. Count me in. I thought I was going to talk longer, so I just took a big mouthful of pizza. So what makes our chapter great is not only the volunteers that are involved, but the community. OWASP Ottawa will always be free. And, well, maybe not free as in beer, but free. We won't charge for your attendance, whether it's a workshop or whether it's a meetup. And so it's that giving of community, having an open educational environment that makes it special. And to that, I'd like to introduce Greg, who kindly offered to present to us to talk about his experiences in DevSecOps, which we're all trying to get our heads around. Particularly, yeah, exactly, in a security environment, having a performant, fast-paced pipeline to be able to push product and features to production. So Greg is a DevSecOps engineer, so he's quite, qualified to be able to talk about that subject. And he works at Rewind, as in pizza. So Rewind is an Ottawa-based startup on a mission to help businesses protect their SaaS and cloud data. So he's curious about cybersecurity, especially in the public cloud environments, and holds multiple industry certifications, including, drumroll please, AWS Certified DevOps Engineer Professional and AWS Certified Security Specialty, which is actually on my to-do list. And as well as the ISC Squared Certified Cloud Security Professional. So I'll have to ask you about that one because that has too many syllables in it. Anyway, so please welcome Greg, who's going to talk to us about his experiences.
Thanks very much for having me. I apologize in advance for wasting your time, but hopefully the pizza will preclude any chairs being thrown my way. Let's see here.
Ditch this. And of course, this is in the wrong. Where is this?
Go left to go right.
Go left to go right. Okay. It's sort of like in a new. Go right. And we will do slideshow. I've been signed. So even though I can see the front page,
technical difficulties. Pardon our
I would
interruption.
just like to say thank you, Google. So should we sign out and sign back in?
Yeah, I think so.
Is it gonna ditch me?
Actually, sign in. Yeah, just sign in right there.
No, it's gonna sign me in as that.
Which is right, because that's what it's shared with.
Oh, okay, yes. Oh, no, it's that godforsaken password.
Don't look, there's no passwords being entered here.
Okay. PASS. He needs a new pair of shoes.
Winner chicken dinner.
I agree, yeah.
There we go. Light show. Look at that success. All right.
Well, that was barely.
Now for death by PowerPoint. All right. Thank you, Garth, for kind introductions and for letting me speak here today. It's hard to believe. It's really almost 20 years of OWASP Ottawa, right? It's going to be 15, right? Yeah. So thank you all for being here and supporting the community. It's nice for once to be on the other side. I benefited for many years from great talks. I hope I live up at least a little bit to it. So a little bit of myself. I'm a DevSecOps chap because we don't really know what that role is. So I'll just call myself a chap at Rewind. Rewind is a local startup. We are on a mission to back up the cloud and restore it in minutes. If you think about it from perspective of what is a SaaS platform? SaaS platform is a product that you procure, a service you procure from someone, but you don't really hold the data, right? If the data, something happens to the data in the back end, the cloud platform vendor doesn't necessarily have your best interest at heart immediately. They're backing up their own data, but not necessarily your data via store, GitHub repositories, or anything like that. So this is a way for you to back up your data and be able to restore it within minutes. A little bit of a tradition at the office is whenever we have a new hire, we bring in a cake. Unfortunately, my hire was during the pandemic, so there was no cake, or cake was a lie. Again, Rewind, we're like I said, we back up a ton of platforms, so very interesting things, for instance, like Jira, Bitbucket, GitHub, and I'll make some mentions of that, but certainly do check us out. All right, so what is DevSecOps? Seriously, I'm asking because we don't know. It's the hottest thing, but no one really has a great definition of it. I like to think of it as Supreme Allied Commander of Software Development Lifecycle Force, short for SAC SDLC, because I'm a big history buff, unlike Ike, which he was the Supreme Commander of the forces in Allied Europe. But in reality, what it is, it's just a partnership. It's a partnership between security folks and all the people that do all the great work to actually build, run, and deliver the product. And DevOps, thanks to Sans for this diagram, I thought it's very apt in this case. It's the loop of continuously coding, building, testing, releasing, deploying, monitoring solutions. So as a DevSecOps engineer, especially at Rewind, I'm very fortunate because I get to work with a lot of cool people. I get to work with our R&D team in terms of the development, with our cloud ops team dealing with cloud engineering, with our DevOps teams and our SRE teams that actually monitor and do that. And the whole process and the whole idea is that I'm a partner and a provider of specialization in making sure that our products are built securely, run securely, and we have this process built from the beginning into the design phase, which is tricky, right? DevOps, it's exciting. There's a lot of investment in this segment. This is from the Linux Foundation. I apologize, it's cut off over there. They do this CI/CD landscape. There is a lot of moving parts to operating a modern application in the cloud these days. It's supposed to be simple, but in reality, it is this, right? Everything from trying to figure out how to do configuration management, pipeline orchestration, testing, messaging, and metrics, and things like that. Which sort of brings us back and we start to think about and abstract is, what are we actually trying to achieve? And I found this paper, I don't know even when it was released, so I apologize, but Cloud Native Computing Foundation released this awesome paper about software supply chain best practices. And I think, when we sort of started thinking about it and having discussions at the office, what are we actually trying to do is we're really just trying to accomplish 5 things. We're trying to secure the source code. We're trying to secure the materials, which is really our supply chain, right? Our dependencies. We're trying to securely build this source code, so have a pipeline that makes sense and is well secured. Then the output of that pipeline has the artifacts have to be reliable and secure. And then ultimately, what it goes into production, into the deployment phase of this, has to make sense, right? We have to have some things in there, whether it's provenance, attestations, and things like that, and operate it while it's in production secured. Which brings us back again to this concept, right? And this is why I think DevSecOps as an idea sort of makes sense, because it's impossible for one person or even for a group of people to be an expert at everything. But if you work with experts in that area, if you collaborate with them, what you can do is you can sort of bring a little bit of a secure mindset to how the product is built, designed, and run and operated. So if you step back and this is one that I really find interesting because, again, OWASP does such great work in top 10s. It must be the top 10 in all of top 10s. CI/CD security and risks. So if we threat model, really, what are we trying to look at if we take those 5 things that we're trying to protect against? What are the potential pitfalls of doing this? How do we operate in there? And a lot of these seem common sense, but in reality, it's a lot of work to try to think like a potential bad actor and try to threat model out what could be wrong, what could go wrong along the steps as we're building software. So we'll touch a little bit on a few of these, but right off the bat, like insecure system configuration, common sense thing, right? But it becomes such a difficult thing when you have so many different products that plug into your pipeline, right? And operating from different vendors with interactions with federated identity and all these things. Something as simple as dependency chain abuse, right? We're so very eager and everyone wants to move fast, build and deploy. But if we don't take a moment and step back, a lot of bad things get injected into that because of the fact that there are bad actors that are taking advantage of this. So I just found this list very interesting. I don't know if it's a new thing or sorry, move the mic. It's a new initiative from OWASP, but I think it again shows value of why we have these communities. And the big thing for us, and I don't know if that actually is Emerson's quote, but it seems to be, it's disputed. It's about the mindset, right? It's not the destination that matters. At Rewind, we've been around since 2015. We've grown immensely. And if you were to look at the source code and the first commits in 2015, first of all, they were made by Mike and James, who are the co-founders, who don't code anymore, as great as they are. They're much better at other things, and we hired a whole bunch of smart people to do this. We've evolved, right? And over those years, we continuously try to think about how do we improve? And as the product scales, as our services scale, as we back up more platforms, the challenges are different too, and the industry evolves. So one of our mantras and one of the sort of things that we talk about is be comfortable being uncomfortable and be on that journey being uncomfortable. So I think it's not about, having a perfect thing that's going to be at the end. I'm not going to give you a model here that works for you. It's a model and a little bit of tidbits of information that worked for us on our journey, how we built it. And there are common patterns, right? Like anything else. But ultimately, it's about getting through that process. So as I'm giving examples, and I apologize, I realize some of the screenshots will probably be pretty small, so I'll try to maybe talk around them. It's about things that we do in the spirit of things with our tooling or the decisions we made, how we sort of architecture our product. But the ideas are similar. They're repeatable, whichever way you go. All right, protect the source code. This is actually one of the really awesome things because I think GitHub is very, very good at this. I will give examples of this, but the same ideas work with Bitbucket, or whether you still are, on Jenkins and run Garrett and things inside your own facility, or GitLab or any of the others. Branch protections. That should be like table stakes. Why are we doing branch protections, right? I know it's funny, we laugh, but if you deploy from a branch, if you have main, or if you have your whatever, your product feature thing, make sure that in the least, you require a pull request before merging with a PR. Why do we do this? Multiple reasons. One is make sure that whoever is committing, there is a check and balance and someone else is actually checking their work. If it just means that they looked at it and said, okay, this isn't completely ridiculous, it's still a good start. Branch protection rules are an amazing way to make sure that you catch oopsies, basically. If you're working in the spirit of everyone in the organization is collaborating in that. Having approvals by someone that is not yourself. Believe it or not, that's a common pattern. You forget to add that. I've seen that. People approve their own PRs, which is great. If it works for you, it works for you. Code owners is something that is, it's very simple to add to your repo, especially if you have teams and that. Make sure that you have someone that if you're maybe committing to sensitive area of your code, whether it's your data models, whether it's your workflows, have someone from, whether it's an AppSec team or someone that maybe is just a security champion in your organization, just have them to do a quick review on that PR. It won't block your entire organization. Make sure that once the PR is approved, no more commits go in without another approval. It's a sneaky way to get around things. Require linear history. Great idea, right? Simple concept, but it works. And that's my favorite. I don't even know why that is a setting that's allowable. Do not allow bypassing the above settings. Why do I have these settings if I can bypass them? But, maybe that's just me. So, why is this important? In this concept, I'm using a little Reimagine Broccoli repo, which thank you GitHub for a wonderful suggestion for a name for a repo, for a demo. If you look at the commits going on, clearly something's off, right? Like there's a good pattern. I have my couple of commits, PRs, and then clearly I'm trying to do the right thing, add code owners, but oopsie, the next commit, I push to main, I update my own code owners file. That seems a little off, right? Like that's why we want protections and reviews. I probably shouldn't be pushing to main to do something as simple as work around the technical control for making sure that there is a proper process in our review of that, right? So simple things. Secret scanning as a push protection. Okay, disclaimer, this is an added cost feature in GitHub. If you if you're on GitHub, certain different source code management systems have this as a freebie or not, but it's definitely one that adds a lot of value. So you have two options: is secret scanning and push protection, right? Why would we want push protection? Well, I am not a very good Terraform guy. There's an entire team of CloudOps people and everyone that are amazing at this. I clearly suck because I tried to commit access keys and secret keys to my AWS account. Not a good idea, right? So when you have push protection, especially if you're doing something at 3 in the morning because you're on the run team, you got paged and you're just trying to do a quick check, it's just a guardrail. And it will prevent you, just give you a nice little unable to commit. It won't tell you why, of course, but at least it'll maybe make you think about, oh, maybe I shouldn't be committing my AWS access keys to, to the repo. And secret scanning without push protection, there's still value, right? The value is in that when you do secret scanning, it will detect if you made that commit and those keys get committed in. Now, it doesn't seem like a lot, but I'm sure that if you ask around, someone knows someone that's on an AWS build that had a lot of EC2 instance costs because someone lifted their keys from a repo and was running Bitcoin miners or whatever crypto miners, right? It's a very common thing. And it's something that's so simple to avoid. Of course, rotate those keys, and those keys, disclaimer, those keys are already dead. So secure hardening for GitHub Actions. So if we go back to what we're trying to accomplish, right? We're trying to accomplish the ability to build code, have an artifact, and push it to production. So part of what it is, GitHub Actions, it's just a workflow system. It's your CI/CD pipeline. And with that, like we saw in the past example, is you obviously want to be able to deploy something. So if I want to deploy my code, my Terraform, I want to build all the infrastructure before I push my app in there, I want to have it connect out to AWS. Well, I can have access keys, which are long-lived credentials, things that can be copied, pasted, and accessed. Or I can use short-term temporal connections using OpenID Connect, which is the recommended way. So in this example, there's a GitHub action that AWS maintains called configure AWS credentials. And basically what you do is you just pass in the access key and secret key into it. Hopefully you're storing it as secret value in your repo at least, so it's not in plain text. And when it runs, what you actually see, so this is the workflow. This is a GitHub action that is going to deploy some Terraform. It connects in and it says proceeding with IAM user credentials. So there are a couple of gotchas there. First of all, when you do that, you need to have an IAM user in the repo, in your AWS account, which means someone's actually maintaining a separate identity for a system-system communication. You have long-lived tokenized credentials that have to be rotated. Usually, if you're a SOC or PCI or something like that organization, you're doing this every 90 days. But if you think about it, okay, I'm doing my thing. I rotated them. Now they're active for 90 days. On day 2, if they get leaked, that bad actor has 89 days worth of access with those keys, right? If you're not doing monitoring and that. So bad pattern. The better pattern, especially if we're doing this, is to use the same configure AWS credential action, but pass in something called role to assume. And all you're doing is you're just passing the ARN of a role. And the role then is getting authenticated as assume role, and it's getting a short-term session token. And that's configurable. So, by default, I think it's 1 hour. So at least if this gets lifted, hopefully, the attacker doesn't have 89 days to do something bad in your account. And on the flip side, this is a very simple thing to configure in AWS, right? These examples are there, and there are lots of ways to secure it. This is just a simple Terraform file that configures a GitHub OIDC endpoint, identity provider endpoint in AWS. And it pulls out some conditions for when GitHub can actually use to authenticate with your AWS account. So first of all, it's assume role with identity. Then what you can do is you can do conditions to restrict, for instance, on the subject from the token, saying, I only want certain repos to connect. Or if you have private runners, you can say, I only want source IPs to be from the pool of runners in my workflows. And the benefit of that is, in addition to that, you can use the idea of scope down permission. So you can build roles with least privilege that say, I know this role is only going to deploy to my ECR, to my container registry. So just give it that permission. That's it. You don't have to have a user that might be repeated in multiple places because you only have one user. You can create as many roles. It's a simple process. And you don't have shared credentials and overly privileged accounts, which makes it a lot less likely that even if this is somehow compromised, that the boom is big. And really, on the AWS side, the way it looks is there's just a new identity provider. It's an OpenID Connect one. And then the role basically says, it is what it is. That's your role ARN, so that's what you specify. And that's the trust relationship that says, in this case, only my juice shop, my fork of juice shop, and my reimagined broccoli repos would be able to connect in. So even if someone somehow manages to fork me or do something, they won't be able to deploy to my account. And again, auditing, monitoring, right? Big deal. You should be doing that. Hopefully we all are. It is CloudTrail. It is an extra cost, but we should enable it. But it gives you then the ability to see when the GitHub action has authenticated, what it has done, and so forth. So this is the idea of how you sort of build that composition, adding layers and layers of security. And why is that important? So if you think about it with GitHub actions, these are workflows, and workflows are composed of actions that enable you to do things. And in essence, all that actions are is someone else's code in a marketplace that you can pull into your own workflow. In this example, I'm using Tenable's TerraScan action, which is their open source thing to scan Terraform and IAC files to get some information about how things are going. And you can see that the source code is actually, that source code for this action lives in GitHub. So you can go in and take a look, right? See what it's doing. But because I'm a joker, I also love to read a lot of logs because that's what I do as a SecOps side of my thing. If I'm going to look at logs, I should have some Chuck Norris jokes in there, right? In the morning, coffee, why not? So there seemed like a really good random joke GitHub action out there. And I put it into my workflow. Seems awesome. I connected into my AWS account. I'm pushing my ECR image. I get my joke. The joke's on me though, because my keys are also included in this, right? And I think about this a little bit more. And this is a contrived example. I wrote my own action just to prove the point. But I'm actually logging the AWS secret key and secret access key by using a third-party action in my workflow. I didn't do my due diligence. I didn't check the code. I don't know the provenance of this GitHub action, right? And this is the idea is be careful what you embed into your pipelines. Because something like this, which seems innocuous enough, it's just a Chuck Norris joke. What could ever go wrong with that? Could actually be a bad actor having either hijacked or typo squatted or built a bad action that then lifts your access keys and sends them off to a C2 server. And this is yet another reason why short-lived credentials, good idea. So it's a great idea and a very powerful tool to build workflows, and especially if you leverage other people's code. But be careful what you're putting in your pipeline, right? This is the idea of a software supply chain. Not only should you know what's in the truck, you should know who's driving the truck and what truck is it driven on, right? That sort of terminology, where we don't want someone doing something where they pick it up at the dock, then they go behind the airport, they step out, a nice little guy walks up, walks in, and then, Goodfellas, I think that's the scene from there, isn't it? So code owners, again, comes back to pull reviews, or as I like to call it, peer reviews. So how could I have prevented this issue? First of all, simple glob saying .github, and this is where actions live, should have been reviewed by someone, right? And this is going back to the concept of if you're going to have security people in your organization, embed them into your workflow, help them help you. And this is a very simple process. I probably would have taken a look at that source code and said, maybe we shouldn't be, echoing out the keys there. Let's find a better joke provider. All right. So the Pandabot version update to keep actions up to date. let's run more actions to keep actions up to date, because our workflows are really composition of someone else's source code. So if we're going to embed software into our pipeline, we also have to treat it like software, right? Software has vulnerabilities, software has new features. Our providers and all of this are always releasing new additions and things like that. We should be monitoring what is actually running our pipeline. And that's what the PandaBot offers, in that you can actually scan with this app, with the PandaBot, to see what your GitHub actions are composed of. And certainly, even in a simple example like this, you can see that there's quickly enough changes that warrant checking out what is actually happening and should I be updating the actions in my workflows. So in a span of 3 days, when I was working on this on the weekend, there are 3 version releases of multiple actions that I had embedded into my workflow, which probably means I should be checking these out, which are pull requests submitted by the PandaBot in my repo, and take a look. Is there an issue here potentially where my GitHub action could have a security issue, and should I be patching this? So it's a little bit of a thing to think about too. And then with that, right, once you're thinking about security patching, you should also think about static analysis, not just of the actions that run this, your code, but also things that are in your repo. So for instance, in this example, what I'm setting up and walking up to is Reimagine Broccoli is just a repo that contains all the Terraform to stand up a container registry, an ECS service, and a load balancer to which I can deploy OWASP Juice Shop and run it inside Amazon, inside of AWS, right? So I have Terraform, which builds services to deploy this on. I should probably be scanning that Terraform code to see if I'm making any mistakes. Again, we have a whole bunch of smart cloud ops people and DevOps people that know how to work with AWS. That's not my specialty. So unless I ask them for help, in this case, maybe at least I can get a little bit of a help from an array of great tools that are out there, whether it's Terrascan, Chekhov, Trivi, there's a whole bunch. I'm sure I'm missing some. And embed it into your workflow. So in this case, when I wanted to play with Terrascan, I haven't used it in the past. So I used it to pull in their GitHub action. It's going to scan my Terraform for me. And then what it's doing is it's actually uploading that output, which is a serif file. It's a standard for how security SAST output from a scanner comes out. And it's going to spit it out into my security tab in the repo under code scanning. And clearly you can see I am not very good at Terraform. So it found quite a few things, right? Like even something as simple as putting up a load balancer, putting up an ECS service, and a container registry. There are a lot of moving parts and things that you can do as a cloud engineer to make sure that it's a secure environment. And this is also why infrastructure as code, and doing this in this pattern makes a lot of sense, as opposed to going through the console and click ops the thing. Minus the fact that it's a great benefit that it's repeatable and all of that. You actually get feedback from these tools that help guide you along the journey. So in this case, what I actually found is there is a good reason. Something that came up is I probably should only allow port 3000 from a specific security group from the load balancer to my web server. So I can just create a pull request from that, do the change, and in the end, it's a couple of lines of Terraform that I found that I made a mistake that were given to me as a suggestion, right? So in this case, in this repo, it's only Terraform that's scanning, but think about the process embedding that flow into any sort of repo you have. Static analysis in whether it's your source code for the web app, backend, whatever. It adds a lot of value because it helps you and guide you along the way to discover these sort of things. And then a shameless plug. Back up your data. Backup, if you run in GitHub, it's a fantastic tool, and you can clone it, you can back it up, but there's a lot of things you don't back up, like the metadata, like all of that. And it's, I'm sort of biased. This company seems pretty good at it. So if you want to take a look, we're up there. Highly recommend it. Okay, so now we have our source code, right? We have our source code compiling. We have our source code checked for security. We know that there's a pipeline. Everything's okay. We know how to deploy it. It has to run somewhere. So now we're going to look at the other flip side of this is how do you secure or how do you improve your security posture of the environment that's actually running, running your infrastructure and is going to be hosting the software. And this is web app example, obviously being OWASP, but the concepts apply to anything else, right? So for us, as we evolved, we made an architectural decision to use ECS, which is the Elastic Container Service from AWS. So I'll sort of use that as an example, but in reality, this could be on anything, right? This could be your own EC2 instance. This could be you running your own Docker instances, EKS, any other cloud. The concepts are the same, right? And what you really have to start with, especially in a public cloud, is understanding what the shared responsibility model between you as the customer and the vendor that's providing the service to you. And every single service has its own gotchas and little differences. So for us, ECS with Fargate makes a lot of sense because AWS takes care of a lot of things. They take care of having hosting the cluster, making sure that we have enough available space if we need to scale up, down, right? They take care of all of that behind the scenes. But there's a lot of things that we still have to take care of. First of all, data. Data is always the customer responsibility. It doesn't matter what shared responsibility model you look at, you're always responsible for the data. Encrypt, 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 right? And the funny thing is, basically, I can summarize the whole ISC squared certification to you, crypto shredding. Every answer, crypto shredding, right? And it is, but that's the only way we can protect ourselves, right? As soon as you hand over your data to a vendor, the only way you can really protect yourself is if it's encrypted and hopefully they don't have access to the keys, or if they do, it's in a managed situation. Network configuration. So we all run in virtual networks in the cloud, right? Like they segregate their networks, making sure that you build networks that have good gaps between them that protect for flow of traffic. That's a big thing. And then ultimately, especially in the case of ECS, and this is sort of what we're talking about, I'm going to use Juice Shop, which is the OWASP awesome tool, especially if you're trying to learn pen testing. I'm going to use Juice Shop to pack in a container and deploy it to ECS as an example. Is there a lot of things that you can do, right? And right off the bat, you see container, hardening, monitoring, patching, right? You're responsible for what you put in a container to run in ECS. So what can be done to make sure that the software that's running in the container is running securely? So the first thing about running, and you can sort of scratch ECS, is anywhere in the cloud as a container, is secure your container's image. So in AWS, there are a couple of really great tools that enable us to build and run containers securely. One of them is ECR, so that's the container registry. And what we have in here is an example of Terraform. This is an example of a workflow in the, sorry, you can't see it, but it's in the Juice Shop, fork of the Juice Shop repo. That's basically just going to build and package all the code in a container and push it up to ECR. And it's really as simple as that, right? Again, a GitHub action, I check out my code, I connect to AWS, I log into ECR, I do some tagging, I build it, and I push it to the repo. Obviously, there's some nuances in there, but it's not a huge amount of effort to set that up. But if you think about all the other things that and the implications of doing that, it becomes a little more difficult, right? So great, my container is up there, but now what is actually up with that container? And one of the things that's really cool is if you run your Elastic Container Registry, they have a service called Inspector, which basically scans the container image for vulnerabilities, both in the OS and the software layer. So then what you can do is if there are any issues discovered, you can use some sort of ChatOps or Jira or whatever integration through Event Bridge rule, through SNS, to page out and tackle those, right? So you want to be continuously monitoring your containers to see, am I running anything that's vulnerable? So it's as simple as really configuring the registry with the ability to do enhanced scanning. That is an additional price, but at least with basic scanning, even if you're running in there, you will get some level of help trying to see if you have any vulnerabilities in there. You can set yourself to scan on push. So anytime you make a commit, you make a new build, you upload it to the container registry, and ultimately what is in the container registry will be in production, right? Because the service is going to pull the container from the registry to run it. So your source code is really in there, right? So what you want to do is you want to be able to at least check it out when it's being pushed. But ultimately, the best value is if you're continuously scanning on a schedule and daily schedule to make sure that you're vulnerable, see if you're vulnerable, if something new popped up. Lots of projects, and especially in microservices environments, there are probably, if you look through your own repos, there's things that you haven't deployed or haven't made changes to for months, right? But if you look back from the time that you checked it out back then to now, there's probably a whole bunch of things that happen either in the container image, Alpine, if you're building off something small and base, or in any of your frameworks or anything like that. So continuous scanning gives you the ability to see and keep track of what's going on and remediate those issues as they pop up. So again, example of just configuration. It's nothing fancy. It's very AWS-ish. But underneath, right, all of this can also be terraformed. So this goes back to my terrible broccoli, or I can say some other broccoli suggestion name repo. Terrible broccoli sounds good. You have the ability to sort of design these things consistently. So if you think also about the fact that the benefit of using infrastructure as code is you can build the security tooling that then is helping you secure your platform, which is a little bit of a mind twist. But it's as simple as this. And all these options, ultimately, whether there's also life cycle policies, so you can move containers out, so you're not keeping very old versions. But ultimately, what you want to get to is this. You have a container that you built that is sitting in your registry that is ready to be used by your service to actually host. But you're also getting insights into it to understand what your risk exposure is. So purposely using OWASP Juice Shop, which is the most widely used vulnerable web app in the world, where you expect that there's going to be some vulnerabilities. I use this as an example, and there's a lot, right? So it's nice to know that before I make a decision to run this software, at least I have a gate that tells me maybe you should take a look at some of the vulnerabilities that are in the product that you're trying to deploy. And Inspector, by any sense of a word, is the only product that does this, right? There's an entire slew of awesome products from Sneak, from Aqua, from a whole bunch of different providers that do this, but the concept is the same. This is about knowing and securing the provenance of the artifact that you're going to deploy, that you're going to use and run your product. Know what your risk and what your exposure is in there before you make the decision, right? And that's where it comes back to, again, DevSecOps and building that secure pipeline. And the cool thing is, obviously, you can dive in and take a look at these, but you also have to apply some human decision process to it, right? So in this case, this particular CVE, at the moment, if we take a look at, there is an exploit available, yikes, but fix available? No. Okay, fantastic, right? So this is where process and building these tools, they're an aid to a human decision-making cycle, right? At some point, someone will have to decide what is potentially an issue here. Is it okay for me to run with this risk in production? And you can see sort of where the second part of the finding is, it gives you ideas where it's coming from. You can know which containers, which image IDs. So you can also trace back and build out that sort of map of where your risks are. So now that you sort of know what your container images are and what is in there, you probably also want to evolve them and build them with your product, right? And one of the key things where it's very important, I think, is to think about how the process of managing those releases happens. And tags and tags immutability feature is huge for that. And what it actually accomplishes is the ability to make a technical gate that says, I will not simply run from head, right? I need to make sure that if I'm going to build, and for instance, at some point fix that CVE, and there is a patch for it, I'm gonna make a new build, there's a new version, whether it's a SHA, or whether it's a tag in your own process, whether you're using Semver or something else. What you wanna make sure is that when I actually make that change in source code, that I can trace backwards to see when that source code was made, not just have a single instance of that container. Containers, they're like farm animals, right? They're not your pets. Let them go. Just let them go. Once they change, they're done. So let's tag them. And again, this is a really awesome thing about the simplicity of using workflows and just the range of marketplace availability of actions is it's as simple as adding a step into your build pipeline for ECR and tagging it correctly. In this case, I'm using Semver as an example. And what's the benefit of that? Well, or SHA rather, not Semver, is that once we push code, we build the image, it goes up to the ECR because we have a new container, we have an entire new container image in our repo. And we can then take a look back and make a decision from our service which version of code we're running based on which version of container we're pulling into our runtime. And the benefit of that too is there's another thing. If someone ever gets malicious actor, whether internal or external, gets their hands on your pipeline, even if they build a malicious container, they still have to know how to deploy that container through the infrastructure as code and update the ECS service to pull that version of the code and run it, right? So it adds an extra gate, it adds another protection layer to make sure that you can separate who is doing the development and who's doing the deployment. Because you can't overwrite latest or head or whatever master tag because it's a whole new container. And then as we see here, so this example, I tagged it to be 1.0. And then as simple of a change, if I want to make the decision to change how my software is running in ECS, is I just have to change, pull a PR in my reimagined broccoli, which is where all my infrastructure as code lives, change the task definition and reference a new image. And the image is, in this case, I was doing bad testing because I wanted to prove my point, goes from latest to 1.0, but that's the release. It's done. After this, I apply, the ECS service reboots and pulls the latest code. Now the benefit too is if I have to revert, it's a pretty simple process, right? So tag immutability, and you can see here the pipeline actually goes through and updates the software here. The awesome thing about it is pipeline tag immutability gives you the ability to sort of build a view into what is running in your container orchestrators. You can trace back. So this here is an example of the OWASP juice shop task, and you can clearly see that it's actually pulling from the latest version. If I do another patch and patch, and you're continuously improving that, but you're getting that flow and traceability. And this then expands onto, okay, so now these things are in production, right? Like they're actually running, you're past the code you deployed. That's great, but you also, oh, sorry, missed up on this one. So this is going back, actually, sorry, one last step. It was out of order, then changed the slides. This is from Sneak, who's a really cool company. I highly encourage you all to check it out. Their blogs are awesome. Some good practices for how to make sure that your container images are actually secure. And one of there's a couple of different things that really stand out from this is using containers that are built for the task. Don't run Windows 2016 server with all services enabled, right? You want to keep it small. Run Windows Server Core or run Alpine or run any of these containers because it reduces the amount of code that's in the container, which reduces the container size, but it also it reduces the amount of exposure to things that are in there that are potentially vulnerable. The other thing about it is, especially with Node.js, and I'm referencing the Node.js 10 best practices here, because obviously OWASP Juice Shop is a JS application, use multi-stage builds. And if we actually look at the Docker container file, the Docker file from Juice Shop, they're applying that practice, right? There's a whole bunch of stuff that gets packed into a container image or needs to happen to build the software that doesn't necessarily need to be there in production, right? Like the build phase doesn't necessarily have to be in the production environment phase of what's there. So what you can do is you can use multi-stage build commands. So you're building as an installer, then when you're ready and you have the package, what you're actually doing is you're just copying files from that container with this from tag to just move the whatever the end product of it is. I apologize about this. This is a little out of context. I didn't know exactly where to put it. But the case in point is be also mindful of what you're doing with your containers and how you're building them. And now, again, this is to the point that I was trying to make earlier is, okay, so now you have this running. We've built these containers, they're deployed. Is the job done? Unfortunately, this is where it gets a little gray area with the DevSecOps, because some people believe at this point we've thrown this over the fence and there should be someone else running with it and just monitoring it. Some people say DevSecOps, the loop goes all the way around. And this is where I think I prefer the idea of be a partner all the way across. And what that means that, ultimately the DevSecOps skill set also requires a little bit of the ops side, not just the dev side of things, and understanding how the cloud works. Because there are things and considerations about how you run software in the cloud, right? Some of the best practices, including like network segmentation, use encryption, create VPCs, private link endpoints, so that you're not pulling registry. If you're doing the deployment, it doesn't go out to the internet to pull from the registry. It goes through the private network of the VPC to pull from a private endpoint. Least privilege, knowing how to build tasks and all doing all these things. It's an entire additional level of complexity that exists there. And this is sort of where it's a gray area. I included some slides here just for consideration. Again, this is just an ECS service. It's a cluster that runs a single service, which is the OWASP JS, a single task, which is the Juice Shop. The task runs in a cluster. You have the service and the task definition, which is basically saying, use this container, expose this port, and all these things. And I think this is where a lot of the problems happen when you don't communicate, and we see a lot of these issues is you see people, I would not want to say that this has been the root cause of some problems that we've seen in terms of news, but if you think about it, it's like, maybe I should store my secrets in a secret store, not on the file or somewhere else. But who's responsible? Is it the developer? Is it the security person? Is it that? So there seems to be like this gap where everyone's standing looking up, I got the ball, and it just falls down and the person goes on third base. But it is an area that's very interesting. And I think when we look at it is knowing how to secure and add a little bit of value, not just on the development side, but having some ideas and some of these sort of like IT system administration skills, knowing maybe segregate your networks into public and private zones, have a DMZ, have a firewall, a WAF, and things like that. Put things behind a load balancer, have some firewall rules, and don't allow everyone from the internet into your area. Just expose the ports that only the service that needs to. And ultimately, what you want to do is just run the software, but there's so much else that needs to happen in the public cloud, right? That it's not just a singular thing. And in the end, you get Juice Shop, which is great, except now, of course, that's the AppSec's domain. And that's a whole different conversation and presentation, because yeah, you can run the best, you can build the best system. You can build the most reliable build pipeline. You can build the most wonderful Terraform, secure AWS environment. But if your code sucks, you're owned.
But isn't SaaS part of DevSecOps?
Yeah, see, and then the loop never ends. That was it. Thank you for letting me rant. Thank you again for Garth and all the organizers. I think this is officially the last meeting of this year, right?
So this is the last meetup for 2023. We take a break to shop for our families in December and plan for the new year. But before we get to that, are there any questions?
Oh.
Yes, you're not off the hook yet. It never ends.
Thank you to IBM and University of Ottawa for the cyber range and hosting this. No questions.
No questions.
I have a question.
Okay.
You mentioned enhanced scanning.
Mm-hmm.
So you mentioned there are multiple movements of data as well, right?
Okay.
Does this cause, I don't know whether it's the right question, but does this cause performance problems during that code development cycle?
Good question. And it's one of these things, it really does depend on how you design your pipeline. So in this example, I'm doing everything post deploy, right? So I'm building my software, I have my artifact, I have my container image, I'm pushing it to ECR. And then in this case, inspector would basically look in there, but at the same time, I could deploy the ECS task and have that image run in production. And that's a choice for simplicity reasons and for the fact that this is a simple contrived example. But in reality, you probably want to have gates. You probably would want to have multiple workflows that would do exactly that. So you want to scan, you want to shift left and left of boom as far as possible, right? Which means don't scan your container when it's running. Probably also try to catch it before it's even deployed. In that case, tools like Sneak and a handful of others that are fantastic at this. You could build your own workflow, have it put in as a gating check on your PR that says that if my container that I'm trying to build as part of this PR has vulnerabilities, and let's say critical or high and above, it will block you from merging. And in that case, yes, then you become a hindrance in the process as a security, because you're trying then to go and work with the development team. Can we remediate these vulnerabilities, before we deploy it? And then, there's always that negotiation: is what's the risk appetite? What's, how important is this feature? This customer is screaming, we need this, the typical thing. But yeah, it is and this is why it's not a science, it's an art almost. And you have to sort of make those decisions what works for you. A lot of the times it depends on your environment, right? Where you work. If you are not really concerned, or if you don't work in a highly regulated environment, that's probably okay, the setup that I gave as an example. If you're running and pushing it into production for, what I'm sure IBM's customers, healthcare, some other people here that work in highly important areas that if there's any downtime, you probably wouldn't risk it this way. So yeah. Thank you.
My question is similar. It's general. Maybe you showed us that from the time we have the data till we deploy it to the cloud, where there is a tool that and there's a tool that we can sync to each other, and it looks pretty smooth. But in practice, I want to know, where you think there is a bottleneck. For example, when you're working, you're like, oh, I wish this had more improvement. You're like, okay, this is a big bottleneck for my work. I don't want this. I want to skip this. I'm looking for a new tool. I'm Googling, like, if there is a new tool that can help. I don't know.
A lot of parts. I wish the tools so I can't, I'm probably aging myself, but I still remember when Hudson was cool. That's pre-Jenkins. So like, I'm excited in comparison to like what we had back then. but there's still a lot of improvements and a lot of growth in this space across the entire spectrum of things. And that's why I sort of wanted to pop up that Linux and Linux Foundation thing with all the products that are there. There's always improvements going on, and that's why we also think of it as a journey at Rewind and not a destination, because we're changing and evolving continuously. And I'm actually going to be transparent. This was a little bit of a greedy thing for me because I tried different things here that we don't necessarily do, in our real environments, or try different tools to compare, right? And it's always an example of that. But one thing that is very consistent, something that we're very mindful about, is developer experience. And the marketing term for it in many ways is shifting left and doing that. We're weary of shifting too far left, because what happens is that developers get just overwhelmed with alert fatigue and things like that. Tools that are helping developers remove that is things that we're always looking for, and any vendor that is mindful of the UX and the user experience for developers is huge. Totally, like having blockers jump. So as an example, one of these tools that we use was doing some security scanning for us, and it would block a PR. But it wouldn't give us information in line on the PR what was wrong. It would just put a red, you screwed up. Great, that's very useful. Now I had to go out, click as a developer, click on another link to open up another window, to go to another UI that I haven't used in 5 years, that doesn't log in because SAML and federated access is in the enterprise version. So we now have user accounts that then you forgot how to do, and those things drive people nuts, and they are real hindrance, right? So anytime that we can have a tool that sort of integrates into the pipeline, that is native integrations with GitHub, why we use GitHub exclusively for so much of what we do, not also the fact that we back up GitHub and we're pretty proud of it, but it's a great tool, right? And everyone's familiar with it, at least in our development, in our range of our sort of tech stack. So I think that's a big thing. The other aspect of it is also on the flip side. One thing that's very difficult is once you're in production and having visibility into what's running and debugging, right? When you develop locally, we have our local dev environment, we have containers that run locally. It is very close to our production environment, but it's not running natively in AWS, right? So there are gotchas and little quirks and shims we put into our dev environments, and there's an amazing guy that actually they spent the past 6 months redeving our local dev environments to make it a little better, but it's still not the same. So a lot of the times what happens is, well, we sort of got it working here and everything's nice. I can't reduce it here. So how do you do this? I think the challenge is, how do you debug in the cloud as a developer? That's another big thing. There are some great companies and great different approaches for how to do it. Some companies have tried, giving a developer their own each environment. You have UAT staging environments and stuff like that, and you go through these gates and workflows and try to reproduce. But ultimately, it's tricky. So those two areas, like any vendor, any improvement, first of all, in making sure that developers don't have to get bumped out to tools they're not familiar with, that are full of alerts that they don't necessarily know how to, what is a CWE and a CVSS, and like this makes sense, right? Like it makes sense to someone that knows it, but to a developer it doesn't necessarily make sense. It just tell me there's a problem with my code, right? Or I'm doing something wrong. And then on the flip side is seeing how there's a problem with my code actually in production or somewhere else.
Works on my machine.
It always works on my machine, right? Sorry, go ahead. It is a big problem, right? And I think especially so for organizations that use open source tools, and we're a huge proponent and supporter of open source environments. We're a Rails shop, so we use a lot of open source components to run our product. We're always looking out for how to improve and how to monitor, our supply chain and what's the provenance and the quality of the gems and the libraries and dependencies we're pulling in. It is a challenge. I think the tooling is getting better. I've mentioned a few examples here of how you can do it. I think this is probably a talk unto itself. I was kind of hoping someone would tackle this on, because I would love to learn a little bit more about how other people are tackling this issue. I think for us, in terms of what we're looking to accomplish, is try to have as many common elements as possible and build out from that. So like having common images, for instance, and we have a lot of services, and a lot of these services have common things underneath. We run a container with Rails and some other things that get pulled in, and having the ability to sort of focus in and test on those. That's a big thing. Having consistency and not having sprawl in terms of frameworks and different things that are in there is a challenge, because we also want to be innovative, but that we understand that sometimes that comes at a cost. So making trade-offs, right? Like one reason that we made, I think, I can, it's probably safe for us to say here, but like the reason we're on ECS with Fargate and not Kubernetes is that we don't want to be Kubernetes experts. It might work for other people. You might have a lot of talent in that area. We don't want to have become experts in that. We want something very simple that just runs our code and our containers. We want to focus on the business side of things. So that's why we also try to abstract as much as possible and go to experts that provide us tooling and things like that as a service that we can rely on. So it goes a little bit both ways. At the developer and the code level, we try to reduce our amount of dependencies that we need to ingest, but ultimately we have to have dependencies. And then at the infrastructure level, we're being mindful to try to have consistency and try to use experts where possible. That's a good question. Like in terms of, we're still small and agile enough of an organization that, our CTO who wrote them, our founder, who is a co-founder, who is now the CTO, wrote a lot of the code and is still the head of our R&D team, and can probably put me to shame in terms of technical skills. So I'm pretty fortunate to work for someone like that in an organization where we have that, and it's still pretty nimble. We have some communities of practice within the organization, security guild. We have some different champions for different things where it would go for review. We would have that discussion, and we'd have a business decision at some point. Is this really valuable, and is the risk there? We have part of a trust team, which I'm in, and we do vendor assessments and things like that to go through the process. So it's not like you just go ahead and dump it, unless it's a hackathon thing and you want to try it out and you'll show the value and then we'll go through it, right? But it is a tricky process. I know it frustrates some developers. Some developers are okay with it. It frustrates me on some things. And events like this are also fantastic for us to learn, right? Like I wouldn't just plug in TerraScan or whatever it's called into my workflow, right? I know that we've vetted and we have a couple of tools that we use that we're comfortable with, but I want to try it out. Maybe this tool is better. Take a look at it. Do something like this. Give back to the community. Make people suffer for having to listen to me and go through my little lab exercise on the weekend thing. But it's different approaches to it. I think we're just fortunate enough that we're still small enough where it's not a big thing. But it definitely can be I know, certainly having worked in different organizations, it's a challenge, right? And then having a process around a proper security team that does this sort of architectural things, it's a challenge. And yeah.
That's it. That's all. Going. Thank you very much.
Thank you.